Okay, in this video we're going to have a look at the frame, and this part of the project is totally up to you really. There's no hard and fast rules that say you have to do this or you have to do that. I'm going to be making a frame out of balsa wood. You can make it out of whatever you like, but generally the idea is you need to keep it light, obviously. You want to have 4 equidistant points in a square that you can mount the motors on. Which should also be in the same plane as well, and try to keep it as rigid as you can. So I have these balsa beams here. I'm not actually going to use these particular ones, but I'm just going to explain my layout with these. And my layout is going to be the H layout like that, because it's very easy to construct and it's easy to keep everything nice and square. And I'm going to use this piece of plywood here, and I'm just going to cut that into little pieces, and I can stick it on to the top and the bottom of this with some screws like that. And this frame, at least with these beams that I originally thought I might use, was going to be something like about a 50-gram frame. So I thought, wow, that's really cool. I'll make it really nice and small and compact and light, and it'll be great. And then I decided that I wanted to try using the power distribution board here that I have as a structural member. So I would bring the middle in like that, and it could sit in there and take some of the structural stress of the frame itself like that. And it also occurred to me that I could put my battery, at least width-wise, it fits quite nicely in there, and I could put it under there if there was a bit more height. And at this point I became obsessed with trying to get the battery inside the main part of the frame and keep it nice and streamlined looking, and I haven't managed to get rid of that idea, even though it's probably not such a good idea. And after that I decided that I wanted to also use my larger batteries that I have a few of. This is the largest one, and it just really wasn't going to work with the thickness of these beams here, which are 1 centimeter square. So I kind of gave up on these, and I went and got another piece of balsa wood, which is 1.5 centimeters square. So that's the one I'll be using in the same layout. But that just means that I can fit my battery in there like that a lot easier. It fits in there just nicely until it puffs up, I guess. But for now it's okay. So that's what I'm going to be doing. And I should also mention that if you're going to be buying a bunch of things like motors and speed controllers and stuff like that, you might as well, especially if you don't have any wood lying around, you might as well just throw in a few more extra dollars and get a frame. They are surprisingly cheap. In fact, when I totaled up the cost of the balsa wood and the screws and what else, the plywood, it came to only a few dollars cheaper than this frame here. But this frame here will be a lot stronger, and it's a lot more convenient to mount things on because all the holes are drilled already. So you've got your 5 centimeter holes there like that, or like that. And again on the bottom, the straps for batteries, mounts for motors, everything's nice and flat. It's quite strong and light. And surprisingly, when I calculated how much this frame is going to weigh, it's the exact same weight as this, which is 74 grams. So if you're not so keen on the DIY part of the frame building, you might as well just get a frame like that, I think. So I shouldn't really recommend this frame too highly because I haven't actually used it yet. But so far it looks pretty good. It's nice and stiff. There's a little bit of flex that way, but otherwise it's quite nice. So what I'll probably do is I'll build this balsa frame and fly it and break it, and then I'll just shift all my hardware onto this frame here for a little bit more of a permanent home for the goods, I think. And another thing that's nice about that frame, or buying frames, is you can get nice parts for them like this, which is a guard for the frame, and I think it might be made to go on this particular frame actually, because it goes on there really nicely. So that's a nice little thing you can get as well. And they also have nice mounts for the motors, at least the motors that I'm going to be using. So I really should stop harping on about that frame, shouldn't I? Oh yes, I was going to build one, that's right. Let me get on with that. Well, I won't bore you with all the details of the construction. I think what I'll do for the rest of this video is I will just put in a few little things every now and then when I come across something that I think that's worth mentioning and that I feel that I have something clever to say about it. I'll just put that in as a note to somebody who may be building this themselves. Right, so here we go. Obviously, one thing that might be helpful is not to have any obstructions underneath the propellers. So you'd want to put your motor at a distance that's far enough away from the central panel that the propeller is not going to be passing over it too much. So this orange propeller here is a 5-inch one, and I don't think I'll be using 6-inch propellers, so I've made it just big enough for a 5-inch propeller. The green one here is a 6-inch propeller, and as you can see it's going to be a little bit too large. It'll probably still work, but not so efficient, I guess. And another thing is where you're going to put your motors on, leave enough space so that the beam is sticking out a little bit, so that the motor is not the first thing to hit the ground. So you wouldn't want to put it like that too much, I expect. So just give it a little bit of protection might help. If you're doing the same kind of build as I am, with the plywood clamps to hold the H-frame together, one thing that's a good idea is to, when you get your positions for your holes laid out, you can just do it on one of the pieces and then tape them together like this. There's 2 of them here, and then you can drill your holes straight through there like that, so that you only need to mark everything out once and you only need to drill the holes once, and then you can use that as a template to drill the holes in the actual bars on the frame as well, and everything should be lined up nicely. Well, here is the final form of the base of the frame. Looks quite nice and tidy. It's turned out to be slightly heavier than I had calculated, which is unfortunate, but not too much. So the final weight, well, it's not final, but the weight of this part here is 85 grams. So a little bit heavier than I wanted, but on the other hand, it is rock solid. So it's actually a lot more robust than I had expected it to be too. So I guess it's okay then if it's a little bit heavier for that. Yeah, I only have 1 nut on here at the moment, so 2 nuts on here. So I haven't even tightened anything up, and it's already really solid. Oh, and the distancing of the motor centers is exact, except for one of them, which just here is 1 millimeter off. So that's pretty good. So I'm glad that I went for this really square design with these square balsa beams like that. It was very easy to work with. Just checking out how I'm going to mount these motors now, and this next point is probably only going to be relevant for people who are also using balsa to make the frame, like I am. Balsa is nice and light and tough and etc., but it's very soft, which is going to cause a problem here, because what I'm going to do is I'm taking advantage of the fact that the motors that I'm using have a little space underneath them like that where you can put a zip tie. It's kind of pushing it a bit really to do this, but hopefully it's not going to damage anything. So you'll have 1 zip tie in there like that, and 1 through the other side, and you can wrap those directly around the the wooden beam like that. And I haven't tried this yet, but I've seen a lot of people doing this on YouTube videos, and it seems to work fairly well, as long as you make sure that the zip ties are in opposing arrangements like that, so that the forces are kind of balanced. But speaking of forces, or pressure points really, you can see that the zip tie here is already starting to squeeze into the corner of the balsa because it's quite soft, and the zip tie has put a lot of pressure in one place. And I haven't even really tightened these up very much. It's on there pretty good, but it's not the final pressure that I would want to apply before I started flying. So that's a bit of a problem. So what I decided to do is cut up a few more pieces of plywood and put them over the spot where the motor is going to fit, like that, just so that the pressure will be on the edge of the plywood here instead of on the edge of the balsa. So because the plywood is hard, it will spread that pressure across the balsa, across this whole edge, instead of just in one place. So hopefully that will be enough to solve that problem. And I have one here that I've actually glued this on. I thought I'd glue these. I don't like using glue much because it has a very final kind of a feeling about it. That's why I decided to go with screws and everything to mount these on here. But anyway, I'm going to go with glue for this part. So that's what it will look like. I should have also drilled a small hole in the middle there before I stuck that on. I kind of forgot, but if you look at the bottom of the motor, you'll see, it's probably a bit hard to see in the video, but the end of the shaft sticks out a tiny bit. So you'll need to drill a hole just small enough to let that shaft have some room to spin. It probably doesn't need to go all the way through this plywood, but just a little depression enough to fit that shaft in. And one other point about gluing, that I heard this in one of the flight test videos. Actually, if you want to check out the flight test video where they make a quad called the Knuckle H quad, which is kind of what this frame is inspired by, really. They do basically the same layout, and they have a bit of discussion somewhere in the video about using glue. And apparently if you use glue in between the plate here and the beam, if you have a crash, it can actually crack the plywood plate. So that kind of sucks, because if it didn't crash, if it didn't break the plywood plate, you could just replace the broken beam and away you go. And you could also use these plywood plates to make another quad. I might try making one with the skinny balsa beams later on. So yeah, don't glue these ones onto the beams. That's what I heard. Okay, we're almost done with the frame now. There's just a couple more things to do. I'm going to mount the power distribution board on top of this plate here. So I just need to make a few holes and attach that. And on top of that, the flight controller is going to need another board on top. So I'm going to use some little nylon spacers and put another board on there like that. Obviously not that one, but another one. And then the flight controller can sit on top. And we also have to consider how we're going to lay out the speed controllers. So the speed controller is this thing here. My one is a little bit butchered from previous quadcopter installation, but we need these two. The red and the black need to go to the power distribution board, and there's 2 plus and 2 minus on each end of this, and these ones on the outside I'm not going to use. So we need to put those onto there like that, and then the 3 blue ones, at least if you have the same model of speed controller as I have here, the blue wires are going to be connected to the motor like that. And the motor of course is going to be here, so that'll bring those connections to about that far, and speed controller is going to sit underneath, just with the red and the black coming up to the top through the middle. So what that's going to look like from the bottom is like this. course, with those wires coming through to the top. I can just do that like that. So those wires are going to be going through to the top like that. The other thing is, of course, we need to get these wires to go out towards the motor like that. So what I've decided to do is just cut a little piece out there. You can see maybe from that angle. Just cut a little groove that's just wide enough and just high enough for those 3 wires to fit in there like that. So that when the plywood goes back on, it's going to hold them quite tightly. So there's not enough room for them to move much. It's probably okay if they are loose there, but I just decided to keep them to make this a point that actually holds them tight as well as letting them through. And that will give us plenty of distance on this side to connect those up. And I'm going to cut the motor wire, the black wire, I'm going to cut that down to just as much as I need, because this black wire on these motors really sucks. It's actually been the cause of a lot of problems for me because it's very stiff and it doesn't bend and flex nicely like the silicone wires on the speed controller does. And it's also single core wire, so it's very hard to solder and get a nice connection on there. So basically I want to use as little of this as I can, really. I don't like it that much. But like I say, these are the cheapest motors you can get probably. Well, I've stuck the speed controllers on, so you can see here the way the 3 motor leads come out the side there, nice and tidy. And there's just one zip tie there to hold the speed controller tight, and from the bottom it looks like that. So there's just enough room for that battery that I want to put in there. One thing that I should have mentioned before is that the speed controllers may get a bit hot when they're running. So that's one reason why I haven't just closed in the top completely with a piece of wood. So I just wanted to get a bit of air through there. Of course I wanted to bring all these wires through here as well, but one other consideration that if you're building some different design is that you might want to let some air get into this area. Okay, so they're stuck on nicely. The last thing to do for the frame is to make somewhere to mount the flight controller board. And the flight controller board is a fair bit smaller than this power distribution board, and it's going to be mounted on top on another plywood plank like that. So these wires will just be soldered in, and once these are soldered down, there's no settings or anything you need to make for them, so it's okay just to slap a cover on there that you're never really going to have to look at that again. The way I'm going to set it up is by using the RF24 radio chip for the radio communication. So I'll want a little bit of space somewhere to put that. Plus it also covers up these open solder joints here, because remember they have battery power on them, so you don't want to be bumping them with wires and stuff. I'm going to use some plastic screws for this because they're quite a bit lighter than the metal ones and they don't carry any current, so just in case there's any current inside that PCB there, it's not going to be traveling up into the flight controller board. And also because these screws are not going to be carrying any structural tensions or pressures, so they don't need to be strong, they don't need to be metal, they can just be flimsy plastic ones, that's fine. And I have a couple of rubber spacer things there which should, I think, help to reduce the vibrations that go up into the flight controller board with all the sensitive accelerometers and gyroscopes and stuff. Okay, that's that done, and that's how it turned out. So I've just stuck it on to the side to show you what I mean, but it just goes all the way through from the bottom. I had to countersink these because they're going to be pressing onto here, and I just have the 2 rubber grommet things in there, so it can actually move a little bit, which is okay. The idea with that is to try and reduce the vibrations that come through to the flight controller from the main part of the frame. Okay, we're pretty much done now, I think. I'm just going to weigh the total weight of everything and see how it turned out. So I have on here everything except for the battery and the flight controller, and it says 198 grams. And if I put the flight controller on this, like I say, this is not the one I'm going to use, but it should be roughly the same weight. That is 204, and with my 1300 milliamp hour battery, the total all up weight is 276 grams. So not too bad. But overall the frame is a bit heavier than I had hoped for, but it's also a bit stronger than I'd hoped for. Let's see if we can weigh the frame only. The frame on its own is 132 grams, but the speed controllers are in there, and they're about, I think they're about 32 grams actually, so it's just on 100 grams for this frame. So about 20 grams heavier than I thought it would be. It kind of sucks. So that pretty much does it for the frame construction. And like I say, I'm not an expert at this by any means, so if you have watched all the way through this and you want to see people that know what they're doing this, you can look at the Flight Test channel. They do a good job. They do all kinds of different frames, so you might want to try something a bit different than this. And also the guy from Flight Test, David Winterstall, has his own channel, and he does a few builds of stuff like this. And he does a pretty good job of explaining things. And just one more thing, if you've been following this design like I'm doing, you'll probably want to cut a couple of slots into the base plate to put a Velcro strap in and hold your battery on there, so that you can put it on there like that to fly the normal way, like having the battery outside. And if you kept enough space in there, or if you have a smaller battery, you can turn it around and place it so that the battery is completely inside. Although the way I've done things, this space is so tight in the middle there that just the extra thickness of the two Velcro straps passing across each other and at the top there is enough to make it so that the base plate doesn't really fit on very well. So just keep that in mind. Right, so that does it for the frame, and in the next video we'll take a look at setting up the rest of the wiring and putting the motors on. Okay, see you next time.